All right, so for those of you who are watching this video, I know that curiosity has gotten the better of you and you want to know why we have to flip the signs when we solve inequalities. So let me see if I can give you a little bit of a theoretical background. It'll be a very short video. I'm not going to get too deep into it all, but hopefully it'll make you feel a little better. So here's a number line, and I want to talk about just an equality first. Things that we expect to be true when we use equalities. So let's say I have the equality x equals 2. Well, what does that look like on a number line? That just looks like this dot right here. X is equal to 2, because this is 1, 2, 3, 4. When I plot this dot, I also can make I can use it to make assumptions about what I know about negative x. So what I'm saying right now is that positive x is equal to 2. And then I might ask myself, what is negative x equal to then? So this is positive x. So what is negative x? Well, negative x really means what is the mirror image, or what is the opposite of x? Well, what is the mirror of 2? Well, if I mirror 2 and I look over here on the other side of 0, it is negative 2. So if positive x is 2, then negative x is negative 2. Now that probably doesn't surprise you. However, this becomes extremely important in how we define greater than and less than. Let's use the same expression, except let's do it like this. X is greater than or equal to 2. And I want to graph that on the number line. So I would take my 2 right here, and I would say anything greater than or equal to should be over here, right? Anything above 2 and above. And then I might ask the other question, which I asked before, which is, well, then what is negative x equal to? Well, negative x is supposed to be the mirror, right? Or the opposite of positive x. So what I would expect is that if positive x is here and above, that the mirror would be at negative 2 and below, which is correct. If I have x greater than or equal to 2, then negative x should be less than or equal to negative 2. So when I find the mirror image of an inequality, I end up switching directions, right? In the first one, I was at a point and above, and now my mirror image is at a point and below. So quite simply, looking over here, the reason that we switch the signs whenever we multiply or divide by a negative is because we're finding the mirror image. And mirror images, as you know, like if you're looking at yourself in the mirror and you're trying to do your hair or doing whatever you do, I guess that's what girls do. I don't know if guys have this problem in the mirror, but you're trying to do something in the mirror and your hand isn't going the direction that you expect it to because it's a mirror image, right? Same thing here with inequalities. We flip the direction of the arrow whenever we find the opposite value of x. So instead of x, we're looking at negative x. So very short explanation. Hopefully that satisfies your curiosity just a little bit. You can take some time to let that all set in. And thank you for being curious.